Hi, my name is Nur Shamira. For my part, I would like to explain about the introduction part of Hplc. So, high performance liquid chromatography (HPLC) is an advanced form of liquid chromatography used to separate the components of a mixture which is analyzed. So, the high performance is the result of many factors like smaller particles of the stationary phase, sensitive detector, and good pump system.
The objective of this experiment is to determine the retention time of a standard solution, which is caffeine. The second one is to identify the caffeine peak in a soft drink sample. And the third one is to determine the amount of caffeine in soft drink sample using the response factor method. Next, we are talking about methodology. In this part, we are talking about HPLC system, basic flow diagram of LC, and instrumentation.
Hi and Assalamualaikum. My name is Muhammad Jamil bin Faizal and I'm going to continue with HPLC system. High performance liquid chromatography (HPLC) is used to separate, identify and quantify compounds in a mixture that are dissolved in a solution. That's first. Second, there are two phases in HPLC, which is mobile phase and stationary phase. Number three, this separation utilize the pressure-driven flow of a mobile phase through a column packed with a stationary phase.
So this is basic flow diagram of LC. The first part is pumping. Diluent is pushed through the system. Next is injection. Sample is inserted into the diluent stream. Then separation. Compounds are separated inside the column. The fourth one is detection. Compounds are detected one by one. And the last part is recording. Data is shown as a chromatogram. They have 6 instrumentation in HPLC. The first one is reservoir for solvents, which is mobile phase. The diluent is stored and the solvent can be water, ethanol, acetonitrile or a mix. It transport the sample through the system. The second one is high pressure pump. The pump pushes the diluent through the system at high pressure. HPLC requires strong and steady flow, so this pump ensures that the solvent moves smoothly through the column and the other components. The third one is sample inlet device. It allows a small amount of the liquid sample to be inserted into the flowing diluent. It connects directly before the column. It designed to avoid disrupting the pressure and flow of the system. The fourth one is column. It packed with solid particles that interact differently with each compound. The column is responsible for separating the mixture into individual components. Fifth one is detector. It identifies the compounds as they exit the column. It measures how the compounds absorb UV light or how they interact with the mobile phase. It sends a signal that shows up as peaks on a graph. And the last one is recorder. It displays the results from the detector as a chromatogram. Each peak shows one compound, its quantity based on peak height, and the retention time.
For the result part, we have 3 chromatogram, which are standard solution chromatogram, chromatogram for Cook, and also chromatogram for Levita. From the chromatogram, we got the retention time in minute and peak area in percent for each compound. For the standard compound, we got 2.482 minute retention time and 6249.48779%. For Cook, 2.481 minute retention time and 7001.12305%. For the Levita, we got 2.479 minute retention time and 1.111511 times 10 in the power of 4%. From this result, we can use the formula of response factor RF caffeine standard to get equal to peak area caffeine standard over concentration of caffeine standard, and we got 6249.49 milligram per milliliter for response factor of standard. For the second formula, we use to calculate the concentration of Cook first. we use the formula peak area caffeine in sample, which is Cook over response factor, and we got 1120 ppm of concentration for Cook. And for the Levita, we use the same formula, which is peak area caffeine in Levita over response factor standard, and we got 1780 ppm of concentration. For the next part, which is discussion, the caffeine standard solution has a retention time of 2.482 minutes, showing the times taken from the injection part to the detector. The caffeine peaks in Levita and Co are identical by matching the retention times to the standard at 2.479 and 2.481 minutes respectively. Levita, with a peak area at 1.112 times 10 to the power of 4, has a caffeine concentration of 1780 ppm, while Cook, with peak area of 7001.12, has a caffeine concentration of 1120 ppm. Thus, it confirms that Levita has a higher caffeine content than Cook.
Last but not least, I'm going to continue with the conclusion. As a conclusion, the HPLC system is a powerful and widely used analytical technique for separating, identifying, and quantifying components in a mixture. Based on the result, both Coke and Levita contain caffeine, with Coke showing a slightly higher concentration based on peak area comparison. The retention time match for Coke strongly confirms the presence of the caffeine, while Levita has slightly lower retention time. Lastly, this experiment is successfully identified caffeine peak in a soft drink by comparing both Coke and Levita caffeine peaks. That's all from us. Thank you for watching.